Okay, this is the second video. Today, March the 18th, 2019. And what we've done is we've connected the 2100 board with the ISO-2. And these are the following connections. We have, for this particular case, 0 to 4 volts DC feedback. And we are actually simulating that. And that's going to be constant, something to keep in mind. But we're doing 0 to 4 here. And what we're doing here, just because I know that in this particular case the customer is bringing in a jumper, we have a jumper between position 4 and position 3. That's just to prove that the board's still working. So we have the same 30 volts DC to power the ISO2 board. We are bringing in the 12 volts from the firing board to the regulator board. We of course are connecting the two commons together. And we are bringing in 12 volts for the voltage command at pin 1 and also at pin 2 on J4. That's the current command. Seek high, it's the signal out of the regulator going into the firing board. And in this particular case, apparently there's no connection, right, Tony, for any of the enables. Which again, we said we could go to the soft inhibit as long as this is pulling out to 12 volts.
Yeah, I got the.
All right. So the first thing that I'm going to show is the way we have it set up is with the feedback shorted out. We brought in the current trip and the voltage trip potentiometers to 100%. We don't want to trigger any trips at this moment for this video. We have both the voltage and the current limit all the way up, and keeping in mind that we are controlling here with our potentiometers because we're bringing in the 12 and we're trimming them with these two potentiometers. Here my sig high is not making any sense. This is no longer open loop, and what we have here is again the maximum output, at least out of the SCRs that we had when we were firing an open loop. We can tell right now that we have that current limit LED on, just as reported by the customer, and the voltage limit is high. Now let's start now with the voltage limit, the conditions of the customer, which will be keeping the current limit maximum, having the current feedback shorted out, and having that LED. Now let's start bringing in the voltage limit down, keeping in mind that here, to make things right, we would have to have this connected to a load that is providing the right voltage feedback. Because we don't, because we still have it, we're basically slamming. Can you do it again? Can you do it again, Tony, please? So all we're doing is, you can see in the scope that the output, it just comes on and on. There's no really regulation. So go ahead, don't bring it down. Okay, and bring it back again. By the way, these are still the same signals on the board. TP7, TP8, and the output across the SCR. All right. Now we can do the same thing on the. Oh, by the way, last thing that I want to show. Can you come back again, Tony? And let's take a look at the. Hold on. Let's take a look at the LEDs. How the current LED it's on, the voltage LED is not. But go ahead, Tony. Start decreasing. There's a crossover at some point, and now the voltage limit's on the current. The voltage limit's on, the current limit is not. So go ahead and bring it back, please. Now we're going to do the same thing with the current limit. It's coming down. And here, because this is a short and it's only 0 to 50 millivolts, here we have some control. We can go all the way to the minimum. And go ahead and bring it back to me, and that will be while keeping the voltage command all the way on. Okay, the last few, so this is the easy way for us to check that at least the connections are okay. Of course, in order for us to check the voltage limit, we will have to bring in different AC voltages to verify that the output it's trying to maintain constant. Now, appreciate if you can show me that I have 4 volts of feedback going. So we're going to come to the isolated part of the. So you go between 4 and 3, and that's 4 volts. Now, when you have 4 volts, and again, this is a standard board, can we go now from common to test point 4? and this is what we reported, and it said, yeah, it's basically the same 4 volts. So now, if your board, if you're bringing in 0 to 10, because R11 and R12 are no longer 31.6K as shown in the standard schematic. This is 0 to 4, these two are 31.6, but if they're not, if they were modified for 0 to 10, you're still going to get 4 volts when you bring in your 10 volts here. Again, it's shorted 4 and 3, and so you should be able to at least have it all connected. This is okay, and then of course we're going to stop here, and if it's needed, we're going to have to put together a rectifier being controlled. It will be a semi converter using 2 SCRs, 2 diodes, and then bringing in different AC voltages to show the regulation. This is the end of the second video.